Hello, my name is Rohan Kulkarni and I'm part of the Mindbuilders FLL robotics team, which was selected to participate in the Norcal Global Innovation Expo in San Jose on March 9th, 2019. In this brief video, our team is going to provide a quick overview of our 2018 Into Orbit Space Garden project, which was selected for our unique innovation around using urine and wood ash to fertilize and grow plants. The problem we are trying to solve is that astronauts on long-term lunar missions have a limited variety of fresh fruits and vegetables. They only have access to bland leafy vegetables, and our research shows that they often crave more flavorful fruits and vegetables like tomato and basil. Our solution focuses on a way to grow a larger variety of fruits and vegetables in space. Fresh food is important in space, and food can cost $20,000 per kilogram to transport. An astronaut might receive one apple to eat per transport mission, and even that they may have to share. This causes astronauts to have a great desire to consume fresh produce. Fresh produce could even improve the psychological health of astronauts by simulating an Earth-like environment.
Our system is efficient in a sense that it uses cheaper and more local materials in order to provide life support. The innovation of our solution involves the use of human urine and wood ash to produce better yield of food from plants in space. We used wood ash to supply the remaining nutrients that urine does not supply. Urine is full of nitrogen, potassium, and phosphorus, which are key nutrients plants need to thrive. Nitrates are used by plants as fertilizer, which is found in urine. In order to get that fertilizer, you take the urea and water and convert that to ammonia and carbon dioxide. Then the ammonia and oxygen converts into nitrite, hydrogen, and water, and then the nitrite and oxygen converts into nitrate. One person's urine can fertilize 6,300 tomato plants per year, which is more than 2 tons of fruit. Our solution can grow more variety of plants and is also cost efficient. It provides emotional benefits, as astronauts feel more happy when growing plants in space, and it also uses localized resources to provide life support. Also enables the colonization of planets and their satellites such as Mars or our very own moon. All of these benefits are available to everyone, including people who live in harsh climates. NASA and the astronauts would also benefit as well.
Our innovative solution that we propose is the ISLS, an acronym that we have developed, which stands for the Innovative Space Life Support System. The ISLS is an improved method to provide astronauts with food, water, oxygen, and the essential needs for survival in space. This model portrays the fundamental process of our solution. The plants are supported by the human urine and carbon dioxide, while the plants produce oxygen and food for the astronauts. This process uses transpiration and photosynthesis. This equation shows how carbon dioxide and water converts to carbohydrates, or sugar, and oxygen. These are some pictures from our experiment. The first picture shows the beginning of our experiment, where we started to grow tomato stem cuttings hydroponically. The center picture is a picture of our mini greenhouse. The greenhouse is where we have 4 basins, each containing a different solution. The third picture is our progress, and it shows that the basil cuttings have grown roots.
These are different types of hydroponic farming. We studied different hydroponic techniques, and we concluded that deep water culture system was the best for our needs. We picked deep water culture systems because it is cheaper and easier to do. It is also easier to set up and clean.
The process we used to identify the solution is that we evaluated multiple options that are available in space to be used as plant fertilizers. We determined the best option based on the parameters like availability, feasibility, hygiene, plant growth, etc. Based on the evaluations of these fertilizer options, we shortlisted human urine using hydroponics as our preferred solution. We chose urine because it is a localized alternative to other commercial fertilizer, which would be expensive to take to space. We looked for self-sustainable options, such as urine, which was a high availability in space. Use of urine helps reduce the dependency on water, which is also scarce in space. Urine has natural nutrients such as phosphorus and nitrogen, which are key ingredients for plant growth. As you can see in the table, we have summarized the evaluation of various fertilizer options, and urine is identified as the best source of fertilizer to be used in space.
Our implementation model uses hydroponics as an alternative growing method in the place of soil. For tomatoes, we use pink LED lights as it promotes plant growth most efficiently. We use extendable bellows so that the model can be folded and stored into a small space. In order to keep the roots in place, we use LEGA, lightweight clay aggregates, and they keep the roots in place in the absence of gravity. The greenhouse model helps reduce the impact due to radiation, cosmic rays, and extreme temperatures. We built a prototype of the greenhouse model to grow basil and tomato plants over a period of 3 to 4 months. The total cost for our implementation model is around $250. Our model can also be used in third world countries where farmers cannot afford commercial fertilizers, and they can instead use our hydroponic solution using urine and wood ash as a fertilizer instead. We spoke to Dr. Jean Giacomelli, who designed the first lunar greenhouse prototype and is a subject matter expert in the field. He told us that we should consider the use of clay aggregates and soil pillows to ensure that the roots stay in place. We also spoke to Jenny Harris to validate our model, and she told us how to efficiently use the hydroponics method.